Hey guys, it's John Kinsey, and I'm doing this podcast on electricity. So, what is electricity? Everyone has the basic understanding that it only goes through metal and is used to power everything. But what is it exactly? Why does it only work when using metal? Why does it need to be in a closed circuit to work? To start this off, we need to take a look at what happens when metals bond with each other. When they bond, electrons on the outermost layer move freely from atom to atom. This is known as the sea of electrons. Electricity is these valence electrons moving in a common direction. This is also why all wires are made of metal, and why things like water don't conduct electricity. There are a few things that can be measured for electricity. The most common are volts, how fast it is moving, amps, how much is moving through it, and ohms, how resistant something is to electricity. Volts are the easiest to explain. How fast it is. It is measured by dividing joules by coulombs. A coulomb is a measurement for how many electrons are being used, which I will explain later on. Amps are a little bit harder to understand. It is a measurement of how much electricity is being moved. A simple demonstration of this is drinking through a thin straw and drinking through a wider straw. You have to suck harder on the thin one in order to get the same amount of liquid you get from sucking normally out of that wider one. It is found by dividing seconds by the number of coulombs that pass through it, or by dividing the power, watts, by the amount of volts. Ohms, that funky Greek symbol, is fairly simple too. To get ohms, all you need to do is divide your volts by your amps. Ohms are a measurement for resistance. For example, a copper wire is going to have an extremely low amount of ohms because it will slow down the electricity flow so little that it's negligible. Things like air have an extremely high amount of ohms, therefore you need a lot of energy to pass electricity through it. For example, lightning. Two interesting applications for electricity is the prevention of rusting and touchscreens. Rusting is where iron loses an electron and bonds with oxygen. Running a small amount of electricity through the object makes it so that when an iron loses an electron, it is immediately replaced due to the electricity. There are two common kinds of touchscreens. The first kind, resistive, is where you have two thin sheets that are electrically resistant. They are separated by a thin space, and when you push down on one, it touches the other. It completes the circuit in that particular area, and a signal is sent to the device. The other way, capacitive, is a little more genius. There's only one layer, and it has a current going through it continuously. When you touch it, you absorb the electrical charge in that particular area, and a signal is sent to the device. This is why you can't use your iPod with most objects. I forgot to mention that all of these things need to be in a closed circuit due to the fact that if there's nowhere for the electrons to go, they won't go anywhere at all. So, coulombs, the hardest thing to explain. Basically, it is a unit equal to the quantity of electricity conveyed in 1 second. It can be determined by multiplying the number of electrons being used by Faraday's constant. For example, in this equation, 2 moles of electrons are being used. Therefore, the coulombs is approximately 193,000. If we put this battery in a circuit and find that it produces 720 joules, then we can use our volts equation to find out that it produces 25 volts. Also, if we found out that the amps are 2, we can use our ohms equation to find out that the ohms are 12.5, which isn't very resistant. Please note that these are made up numbers and probably not accurate. Now we can go into how batteries work. They are galvanic cells that in their basic form look like this. What happens is that the electrons move through the wire across the top, and so the light bulb ignites. The copper side will start giving off electrons to the aqueous copper, turning them into solid copper, while the solid zinc will lose electrons, turning it slowly into aqueous zinc. Well, that's all the time I have right now, but thanks for watching, and a special thanks to TT Alexander 2 for the music. Alright, see you later.